SpaceX just dropped the biggest Starship news of 2026, and it changes everything. Flight 13 is locked in for July, then Flight 14 in August, then monthly after that. 6 more Starship launches before the year ends. 2 weeks ago, most people still thought Starship flew once every few months. Now SpaceX's own COO, Gwynne Shotwell, stood in front of the world and confirmed a monthly launch cadence, live on IPO day, with a $2 trillion market cap behind her. And Flight 14? That's the orbital injection attempt, the one where SpaceX tries to catch a returning ship at the tower for the first time. This isn't a rumor, this isn't a leak, this is the official plan. And the timeline just got brutally real. Stay right here, because the details are wilder than the headline. Let's start with the number that matters most right now, July 2026. That is the official launch window for Starship Flight 13. Not a rumor, not an estimate from some analyst on Twitter. This came directly from Gwynne Shotwell, SpaceX's president and COO, on one of the most watched days in the company's entire history. And here's what makes that date so significant. SpaceX didn't announce Flight 13 in some quiet press release buried on their website. They announced it on IPO day, in front of the entire global financial market, with $2 trillion in market cap on the line. When a company goes public at a $1.77 trillion valuation, every word their executives say carries legal and financial weight. So when Gwynne Shotwell looked at the cameras and said, Flight 13 launches in July, then Flight 14 in August, then monthly after that, she wasn't being optimistic. She was making a public commitment to every investor, every institution, and every government on Earth that just bought into SpaceX. That's a different level of pressure than any Starship timeline we've seen before. But here's the part most people glossed over in the IPO coverage. It's not just the date, it's what Flight 13 is supposed to do, and what it's deliberately not supposed to do. Flight 13 is going to be a suborbital mission, same profile as Flight 12. Now, before you click away thinking that sounds underwhelming, stop. Because the reason SpaceX is doing this is actually a story about engineering discipline, and it tells you more about how this company thinks than almost anything else. Here's the situation. Flight 12 revealed serious problems, but not where most people were looking. Everyone focused on the ships, the debris, the explosion over the Caribbean. That was dramatic, sure. But the deeper issue, it came from Booster 19. There were anomalies during the boost-back burn. Then the landing burn failed. The booster, the giant first stage that SpaceX has now caught multiple times with their mechanical arms, did not perform cleanly. So SpaceX is now flying Flight 13 with Booster 20 and Ship 40, a fresh pair of hardware. And the goal is simple. Get a clean run on the books, confirm the fixes work, rebuild confidence in the system before pushing to the next level. Think of it like this. You're a racing driver. Your car had a brake failure in the last race. Before you go back to full racing speed, you do a controlled lap. You confirm the brakes work. You don't try to set a lap record on the first run back. That's Flight 13. And here's the technical detail that matters. Both Booster 20 and Ship 40 are now equipped with all Raptor 3 engines, 33 on the booster, 6 on the ship. Raptor 3 is a significant upgrade over what flew before. More thrust, better efficiency, simpler design, and both vehicles have already gone through cryo testing. Static fire for Ship 40 is happening at Massey's test site. Booster 20 fires at Pad 2. Both are expected very soon. And here's the setup for what's coming next. The reason Flight 13 has to be boring is because Flight 14 cannot be. Flight 14 is where everything changes. Gwynne Shotwell said it clearly. Quote, I hope we at least attempt an orbital injection on Flight 14. Let that word land. Orbital, not suborbital, not a high arc that comes back down. Orbital injection means Starship, for the first time ever, completes a full trip around the Earth. And that's not even the biggest part of Flight 14. The biggest part is what happens to the ship when it comes back. For the first time, SpaceX is planning to attempt catching a V3 ship, the upper stage of Starship. with the mechanical arms at the launch tower. They've caught boosters before. Booster catch is now almost routine, but catching a ship that has re-entered Earth's atmosphere at hypersonic speeds, survived temperatures that would melt steel, and then has to come back and hover precisely into the grip of two giant arms? That has never been done. And what happens next is where this gets genuinely dramatic. The ship that will attempt this catch is Ship 40, assuming it flies successfully on Flight 13 first. If Flight 13 goes clean, Ship 40 becomes one of the most important pieces of hardware in aerospace history. If something goes wrong on Flight 13, SpaceX has to make a call. Do they push Booster 20 for a catch attempt anyway? Do they hold back and do another clean water landing? My read, and this tracks with how SpaceX has handled every major transition, is that they will not attempt a Booster 20 catch on Flight 13, not after what happened with Booster 19. They need one clean, unambiguous data run before they put the catch tower at risk. But here's the thing that nobody's talking about enough. A ship catch attempt is fundamentally harder than a booster catch. Here's why. When the booster comes back, it's relatively controlled. It's a massive cylinder that slows itself down with a series of engine burns. The mechanical arms, the Mechazilla system, grab it from the sides as it descends slowly. A ship re-entry is completely different. The ship comes back belly first, using its heat shield tiles to absorb the energy of re-entry. It's essentially skydiving at hypersonic speed, using aerodynamic drag instead of engines to slow down. Then, in the final moments, it flips vertical and uses its Raptor engines to hover. The precision required for a catch attempt, given all those variables, is almost absurd, and SpaceX is planning to try it for the first time in August. Drop a comment right now. Do you think Flight 14 lands a clean ship catch on the first attempt? Yes or no? Let's go back to June 12th. Because what happened on that day was not just a financial event. SpaceX went public. Ticker symbol SPCX on the NASDAQ. The IPO raised $75 billion at a $1.77 trillion valuation. That pushed past $2 trillion during the trading day. Shares opened up 11%, hit a high near $176, and closed up 19%. And here's the human story inside those numbers. The IPO reportedly made Elon Musk the world's first trillionaire. It created approximately 4,400 employee millionaires inside the company. A welder, someone who works with metal and fire, not stock options and spreadsheets, who received an early $10,000 stock grant, walked out of that day with $880,000. That's the scale of what SpaceX built, and Elon Musk rang the opening bell, virtually, from Starbase in Texas. And he said something in that moment that you need to hear. He said he gave SpaceX less than a 10% chance of succeeding when he founded the company in a warehouse in El Segundo in 2002. Less than 10%. That's not false modesty. That's an honest assessment of what it takes to build a rocket company from zero. Most rocket startups fail. Most of them fail fast, and they fail expensively. SpaceX didn't fail, and now the company that almost didn't exist is the most valuable aerospace company in human history. But here's the part that matters for Starship specifically. Going public creates a new accountability structure. SpaceX is no longer just accountable to Elon Musk's vision and a small group of private investors. They are now accountable to public markets, to quarterly reporting, to thousands of institutional investors who expect progress to match the promises made on IPO day. That means the monthly launch cadence Shotwell committed to isn't just an aspiration. It's a financial obligation. And that changes everything about how aggressively SpaceX will push the Starship program in the next 18 months. The factory that will feed it all. Here's the part of this story that most YouTube channels aren't covering deeply enough. Launching Starship monthly isn't just about the launch pad. It's about production. You need a continuous pipeline of boosters and ships being built, tested, and ready to fly. Right now, SpaceX operates out of Gigabay 1 and Gigabay 2 at Starbase in Texas. That's the current production system. It's impressive by any normal standard, but it was never designed to support the scale SpaceX is now planning. Enter the Gigabay. This week, SpaceX completed the last level of structural steel on their new massive production facility at Starbase. The building is now structurally complete, and the numbers are staggering. 24 bays under one roof. To put that in perspective, the current setup has 2 megabays. The Gigabay has 24. That's a 12-fold increase in production capacity under a single roof. When this facility is fully operational, SpaceX will be able to build and prepare multiple boosters and ships simultaneously at a scale that no rocket manufacturer in history has ever attempted. And why does SpaceX need that much capacity? Because the demand pipeline they've committed to is genuinely colossal. NASA's Artemis program needs Starship to deliver the human landing system to the moon. SpaceX's own lunar base plans require a continuous flow of hardware. They've filed for a 1 million satellite AI compute constellation that needs Starship launches to deploy. And those are just the programs that are publicly announced. The Gigabay is an ambition. The Gigabay is the only logical response to the demand that already exists. Here's the honest caveat, though. The building is structurally complete, but it's not operational yet. SpaceX still needs to clad the entire structure, install heavy gantry cranes, and fit out the interior workstations. Realistically, that takes another 6 months or so. But here's where SpaceX does something that consistently surprises outside observers. They don't wait for finished buildings. With both Megabay 1 and Megabay 2, prototype construction was already happening inside the buildings long before they were officially finished. SpaceX starts the moment any usable space is available. That's not recklessness. That's a deliberately cultivated culture of forward momentum that is almost unique in the aerospace industry. So while the Gigabay won't be done for another 6 months, there's a very real chance we see hardware being moved in and worked on well before then. The pad that's being rebuilt from scratch. Let's talk about something that's flying under the radar, but shouldn't be. Pad 1 at Starbase is being completely rebuilt. And when I say completely, I mean they are ripping the old structure out of the ground, piece by piece, and starting over. Heavy excavators with jackhammers are currently breaking apart the rebar-reinforced concrete piles that were driven into the soil for the original launch pad. Dozens of them. Gone. Removed. Cleared out to make way for a completely new flame trench design. At the same time, concrete is being poured for 2 new flame trench walls. One wall is structural. The other has the GSE bunker, the ground support equipment bunker, integrated directly into it. And the new OLM box, the square structure that forms the base of the launch mount, is taking shape in its own staging area nearby. Already in an advanced stage of assembly. Once finished, it gets lifted and integrated into the new pad socket. What does all this mean in practical terms? It means SpaceX is moving from 1 operational Starship launch pad to 5 simultaneously. Think about that for a second. Right now, Pad 1 at Starbase is under construction. Pad 2 at Starbase is the current operational pad. At Kennedy Space Center in Florida, Pad 39A is being prepared for Starship operations, and SpaceX is aiming to have it ready before the end of 2026. And at Space Launch Complex 37, also in Florida, the first segments of a brand new Mechazilla tower have just begun stacking. 4 pads at various stages, with signals that at least 1 more tower is coming in Florida. And here's the historical reference that puts this in perspective. When SpaceX stacked the first segment of the Mechazilla tower at Pad 39A back in June 2022, they went from that first lift to a fully stacked tower by early October of the same year. About 4 months. Now, in 2026, with all the experience and tooling they've accumulated, the timeline at SLC 37 could be even faster, which means by the end of 2026, we could realistically be looking at a second stacked tower at the Cape, ready for outfitting and approaching operational status. 5 pads, monthly flights, a 24-bay production facility. This is not a rocket program anymore. This is an industrial system. While Booster 20 and Ship 40 are running through their final test campaign for Flight 13, the hardware for Flight 14 is already taking shape. Booster 21 is currently visible inside Megabay 1. Right now, it's in lower section form, the oxygen tank assembly, without the engine section attached yet. But it's already in the queue, already being built, already positioned to be the booster that either attempts a catch on Flight 14 or does another clean water landing depending on how Flight 13 goes. The Moon Rovers. And the problem nobody's talking about. Now let's connect Starship to something bigger, because the monthly launch cadence isn't happening in isolation. On May 26, 2026, NASA made an announcement that surprised most of the aerospace world. They were supposed to select one lunar terrain vehicle, one moon rover, to carry Artemis astronauts across the lunar South Pole. They selected two: Astrolab's CLV-1 and Lunar Outpost's Pegasus. Each received roughly $220 million in task orders. And Intuitive Machines, the company many analysts had pegged as the frontrunner, was not selected for this round. Why two rovers instead of one? NASA's new administrator, Jared Isaacman, made the call. His logic was direct. Picking one rover creates a single point of failure for the entire lunar surface program. Picking two creates competition, redundancy, and a faster path to a real lunar economy. Congress was pushing in the same direction, with language specifying that NASA should select no fewer than two providers. So what are these rovers actually like? CLV-1 from Astrolab is built around a concept called wheel-on-limb. Each wheel sits at the end of an articulated arm, like a leg, rather than being bolted to a fixed chassis. This lets the rover raise and lower its entire body, stay level on steep slopes, and even crouch down to pick up modular cargo containers off the ground. It's essentially its own forklift. And because the solar panels are mounted on the sides, the rover can crab walk, driving sideways, to keep its panels aligned with the low-angle sun at the lunar South Pole. At those latitudes, the sun never rises high. It just skims the horizon. CLV-1 is specifically engineered for that environment. Pegasus from Lunar Outpost is a completely different philosophy. Strip everything unnecessary, build it fast, build it proven. The rover carries two astronauts side by side in a design that looks like a direct descendant of the original Apollo lunar roving vehicle from 1971, because in many ways it is. General Motors supplies the battery and electric propulsion. GM built the wheels, suspension, and drivetrain for the original Apollo rover. Goodyear supplies the tires. Airless metal mesh, using alloys engineered to stay flexible in lunar temperatures that swing 280 degrees Celsius between day and night. These aren't new ideas. They're refined versions of hardware that worked on the moon 50 years ago. Both rovers target 2028 for lunar deployment. Both will be delivered to the surface by Blue Origin's Blue Moon Mark 1 lander. And here's the problem. Blue Origin just suffered a catastrophic incident during a hot fire test of New Glenn's engines. The timeline for New Glenn returning to service is genuinely uncertain. And without New Glenn flying reliably, the Blue Moon lander schedule is at serious risk. This is the tension at the heart of NASA's 2028 plan. The rovers can be built. SpaceX can launch Starship monthly. But the connective tissue, the lander that actually gets those rovers to the surface, is sitting on a question mark right now. How does SpaceX factor into this? Astrolab has already signed a commercial deal with SpaceX to fly a rover on Starship. That deal is worth over $160 million from paying customers. And Lunar Outpost has 9 contracted missions on their manifest, including building Australia's first lunar rover. The commercial momentum is real. The hardware is being built. But the infrastructure chain has to hold together end to end. And right now, that chain has a weak link. The bigger picture. What this timeline actually means. Let's zoom out. Because when you line up everything we've covered in this video, a picture emerges that goes beyond any single launch or any single rover. Here's the timeline as it actually stands. 4 flights, 4 months, 1 per month. That's the new standard. Now compare that to where we were just 18 months ago, when getting a single Starship flight off the ground was a months-long process involving FAA licensing delays, hardware anomalies, and launch scrubs. When a successful mission meant the vehicle didn't destroy the launch pad. The pace of development in this program is almost without precedent in aerospace history. Not because any single breakthrough happened, but because SpaceX built a system, production, testing, launch infrastructure, supply chain, that compounds on itself. Every flight teaches them something. Every lesson gets implemented immediately into the next vehicle. Test articles at Starbase are running cryocycles right now, feeding design data directly into Ship 40 and the vehicles behind it. The Gigabay will multiply production capacity 12-fold. 5 launch pads across 2 states means no single pad failure can ground the entire program. This is what a mature industrial spaceflight system looks like in its early stages. And here's the twist that I think is genuinely underappreciated. SpaceX going public changes the incentive structure for the entire industry. When SpaceX was private, their competitors could argue, reasonably, that the valuation was speculative, that Starship's commercial potential hadn't been proven, that investors were betting on Musk's reputation, not on verifiable cash flows. That argument is now harder to make. A $2 trillion public market cap, validated by public market pricing, sends a signal to every aerospace program on Earth, to Boeing, to Arianespace, to JAXA, to Roscosmos, to every government space agency that has been watching Starship with cautious optimism and hoping it would stumble. The stumbles are being iterated away, and the capital to keep iterating just got $75 billion larger. So here's the question I want you to sit with. Every piece of this system is now moving at the same time, and none of it is slowing down. What happens in 2027? 6 launches, 1 year. That's not a prediction anymore. That's a schedule. If this breakdown helped you see the bigger picture, hit like, share it, and subscribe to the Space Brief. Drop your Flight 14 call in the comments. I read every one.